How about I show you a roadmap to scoring perfect scores on your external exam? Sounds good? Well, come along with me as I work through a paper 1, which is a non-calculator paper on the higher tier. In a few weeks from now, students across the world will be sitting their external exams. Yes, after 5 long years of secondary education, you have now reached your ultimate moment. Maths is universal, so whether you're doing your GCSE with AQA or Edexcel, or you're in the Caribbean doing your CSEC exams, I've got strategies to help you navigate any exam question with confidence. So now that you're here and I'm here, let's break this paper down step by step and get you exam ready. Okay, so now that you have read the instructions on the front of your paper, remember this is a non-calculator paper, which means that you cannot use a calculator. So I would suggest that even though a question looks simple, you make sure that you write down as much as you can so you can visualize what you're doing. Now, before we get started in the question, just a quick reminder here. Always underline key things in your question so that you give yourself the focus that you want on what you're asked to find, paying particular attention to any degree of accuracy you may be asked to do in the question. Now, we're going to be working through this paper, and as I go along, I'm going to be giving any little tip I know will be useful to you as a student. Now, our first question here asks us to circle the decimal that is closest in value to 3.019. And we will circle our answer. This is just repeating, reminding you what they want you to do. So it says circle, do not go ahead and underline. Make sure you follow exactly what you're asked to do. Question is worth 1 mark, and you might just be tempted to just have a look and just go ahead and circling. But no, still apply principles. So we're asked to test them against 3.019, so I'm going to put an underline under that. Now, a good practice here to approach this question is to write the original value down, which is 3.019. I'm just going to put a star so that I do not mix up my original with what I'm comparing it to. So I'm going to write my first one, which is 3.2, making sure I line up the decimal points. Then I've got 3.01, 3.025, and 3.19. Now that I've done that, I'm going to seek to eliminate values that will not be comparable based on the place values. Now, if I look at the 10th place here, I can see that the original has 0 in the 10th place, which means that this one is not an option 3.2 because that's already much larger than the value I'm comparing it against. Now, also, this value 3.19, the 1 in the 10th place is already much larger than the 0. So those are eliminated. It means then that my values or my answer would either come from 3.025 or it's going to come from 3.01. So what I'm going to do now is to test that value by subtracting them to see which is closest. So for the first one, I'm going to do 3.019 and I'm going to subtract 3.01. So I'm just going to put a placeholder here. So 9 take away 0 is 9. 1 take away 1 is 0. 0 take away 0, 0. And I can see for this answer, it's 0.09. Now I need to test 3.025 to see if it's closer than 0.009. So I'm going to subtract the original number from that one. So subtracting, I'm going to need to take 1 from here, so 15 take away 9 gives me 6. Then here I'll get 0 in this column, 0 take away 0, also 0. So now I'm comparing 0.009 and 0.006. I can see 0.006 is smaller, and the value that came from was 0.025, so that's my answer, and I go ahead and circle this. Now you may say this is just a 1-mark question. Remember, the difference between 2 grade boundaries is a single mark, so you do not want to do anything that prevents you from getting onto the higher boundary, and that's why this is important to do. Also, it helps you to calm yourself down in your exam as well. It's your first question, and if you are able to get your first question correct, it kind of gives you that positive momentum going into the other questions as well. So on we go to our next question. In this question, we're asked to say, what is 1.4 centiliters as a fraction of 80 milliliters. Now we're going to remind ourselves of the conversion unit. So I like to use acronyms. So kind, honest, determined ladies develop credible morals. A very beautiful way to remember your conversion units without actually knowing them from your brain, because you can use this acronym to find anyone you want. So in this question, I'm going from the milliliters to the centiliters. So I'm just going to label from the one I'm going to the one I want to go to. So 10. So 10 milliliters is equal to, and I'm going to write that down. So 10 milliliters is equal to 1 centiliters. Now remember, if we're comparing units, they have to be the same. So I have to convert, and it's best here to convert my centiliters to milliliters as well. So I'm just going to multiply 1.4 times by 10, which gets us to 14. Now that they are the same, we can now compare them. So I'm going to do 14 as a fraction of 80. And then I can see my answer isn't there, which simply means I have to simplify in its lowest form. So we go ahead, we look for a common factor of 14 and 80, which is 2. So 2 into 14 goes 7. And then half of 80 is 40. So my answer is 7/40ths, and I was asked to circle that answer. So therefore, I've got 7/40ths. 2 marks already in the bag. And we go on to question number 3. Now, we're told here that a transformation is performed on shape A given the image B. Shape A and the image B are not congruent. So if I'm going to talk about not congruent, I first of all need to know what is meant by congruent. Now remember, 2 shapes are congruent. 1, they are the same shape and also exactly the same size. So we are asked here, what was the transformation? And again, circle your answer. A very nice, smooth start to this paper. So we are going to analyze the shapes one at a time. So we're told we're given rotation as an option. Now, if I rotate a shape, the shape will still be the same shape. Size doesn't change even though the orientation changes. Therefore, rotation could not be the option. Notice here, I am eliminating stuff as I go along. If a shape is reflected, the orientation will change because it will be a mirror image. However, the size of the shape and the shape itself remains the same, so reflection is not an option. Translation. If a shape is translated, it moves along a straight line to another location, but it still maintains its original size and also the look of the shape. So again, that's not an option. However, if a shape is enlarged, it could either be bigger or smaller if we have a fractional enlargement, which means here our answer then is enlargement. I hope you notice the logical thoughts I've put into answering the question. I am eliminating, but I am doing some cognitive discussions as I go along as well. Okay, so that will be 1 mark for that question. Now our 4th question here asks us to simplify. So we're asked to simplify 3b plus 2b times b minus b squared, and we are to circle our answer. Now the first thought that should come to your mind here is the order of operation, BIDMAS. So I would encourage you to write that down. So BIDMAS. I've got BIDMAS here. B is for my brackets. I do not have brackets. I eliminate that. Indices, though I have an indices here, nothing to apply. So indices crossed out. Division, there is no division, so I eliminate that as well. But I do have a multiplication. So what I'm going to do, I'm going to underline that multiplication and I'm going to carry that through. So I have 3b, nothing to do with that yet. However, 2b times b gives us 2b squared. And then we are going to do our subtraction. So there is no addition. So strike that multiplication, or rather tick it because we've done it already. Then we're asked to do addition. We can see here in terms of like terms, there is nothing to add in those like terms. So we can go along and do our subtraction. So it's going to be 3b plus 2b squared, take away b squared, will just give me b squared. So my answer then is 3b plus b squared. So again, another 1 marker, but it is very important to work it out. Even if it's multiple choice, you work it out so you can visualize what's going on. Remember, you are under exam pressures, and the simplest of question is easy to make a mistake on. So you give yourself the advantage by inking what you are thinking, and it's so much easier to pick up errors when you do that as well. Okay, so we go on to question number 5. Here, worded problem, 3 marks. So this is very important here for us to pick out the numbers from the words. So Dan can paint 4 fence panels every 2 hours. So I'm going to underline 4 fence panels and also 2 hours. So I'm going to also write that down. I begin to take things out of the worded question and make them more visible to myself. So I'm going to write Dan and 4F for fence panels, and he does that in 2 hours, which we can also write as 120 minutes. Now we go to the next part. We're told Liz can paint 1 fence panel every 15 minutes. So I'm going to go ahead and I'm going to write Liz 1F for fence panel, and she's done that 15 minutes. We can see here we've got minutes and we've got hours, so it's best to neutralize them, and also to neutralize them in a common time. So the reference point here would be 1 hour, which is 60 minutes. So if I write for Dan, in 1 hour, if he does 4 fence panels in 2 hours, then he will do 2 fence panels in 60 minutes, which is an hour. And if I scale Liz up by multiplying by 4, she will do 4 fence panels in that same 60 minutes. Okay, now the question says a garden has 21 fence panels. Working together, very important here, working together, combining their efforts. How long, so we're looking at time, will it take Dan and Liz to paint the panels? So because it's together, I'm going to add 2 plus the 4, so 2 from Dan, 4 for Liz, which means in an hour they can do 6 fence panels altogether. I want to find out how many how long will it take them to do 21? So I now need to do 21 divided by 6. Again, this is a non-calculator paper, so the column method will be very useful here to do this division. So I'm just going to set that up. 21 divided by 6. 6 into 21 goes 3 times. 3 times 6 is 18. That leaves us with a remainder of 3. 3 into 6 is not possible, so that will be 0 times, and then I put a decimal point and add a 0. So 6 into 30 goes 5 times. We were specifically asked, so I go back to look at my degree of accuracy here. I was asked to give my answer in hours. So therefore the answer is 3.5 hours. Nice and smooth, 3 marks there. Well done. Okay, so we're now going to move on to another question. So this question asks us to work out 2/3 squared plus 1/4. Again, we look into orders of operation, so BIDMAS. So BIDMAS says, I love to write them out, so BIDMAS, BIDMAS says bracket first. Now I'm taking care of my bracket here. I'm asked to square 2/3, so I write that out. Simple question, but visualize it. So 2 times 2 here is 4, and 3 times 3 is 9. So I have finished my bracket, which also took in a little bit of indices. There's no division, there's no multiplication, so now I can go ahead and do. So I've got 4 9s, which I got from the bracket, and I'm now adding that to 1/4. I know I cannot add together 2 fractions. The denominators are the same. So I need to find the lowest common multiple of 9 and 4, which is 36. So I need to multiply this fraction by 4. Remember to multiply both numerator and denominator as well, and also this side by 9 to scale up to 36. So 4 times 4 gives me 16, and 4 times 9 is 36, and I'm adding that to 1 times 9, which is 9, and 4 times 9, sorry, which is 36. So we can go ahead and add our numerators. Remember, we do not add the denominators. So 16 and 9 gives us 25. So the answer is 25/36. Having done that, we're now going to go on to part B. Part B asks us to write 2 to the power of 20 divided by 2 to the power of 3, and that's being raised to the 4th power. However, we're specifically asked here to give our answer as a single power of 2. Now, a common misconception here is to think that our power should be 2. No, it's the base that actually should be 2. Now, if the question had said give the value, we would have to work out the power to the fullest and give an actual answer. But this one specifically asks us to leave it as a power of 2. So we go ahead and we do our brackets first. I'm going to rewrite 2 to the power of 20. I know when I have a power to a power, using the power to power rule, I need to multiply the indices. So 3 times 4 is 12. Now, after doing that, I know when I'm dividing 2 indices and the base is the same, I subtract the powers. So therefore, my base is 2. 20 take away 12 gives me 8. So now I have given my answer as a power of 2, and that's because the base in this question is 2. So the answer is 2 to the power of 8. Make a little tick there, clarity, and you have your answer. You check and make sure your degree of accuracy is what you were asked to do. Please ensure you look if the questions say give the value, because if that's so, you would have had to multiply 2 by itself 8 times and get the final answer. Okay, moving along. Part C asks us to write 0.0042 in standard form. Now remember, a number written in standard form is always in the form a multiplied by 10 to the power of n, where a has to be a number from 1 and below 10, cannot be a double-digit number, and n is our index, which could be either a negative or a positive, could also be 0. So I want my number, my decimal has to be between 4 and 2. So from here, I can see I need to go 1, 2, 3 places. But remember, when I have numbers below 1, my power will be negative, and that's because I've made a movement to the right. So the answer then will be 4.2 times by 10 to the power of negative 3. I could also just do a quick check to see, is this correct? So if I do 4.2 and I go 3 places to the left, 1, 2, 3, I can see here I would have gotten my original number back, which tells me I'm correct. Just make sure, if you do that rough check, make sure it is separate from your answer so your examiner isn't confused which one is your final answer. And remember, in an examination, your answer line is the most important part of that paper. Let's say, for example, you did 2 different working out because you weren't quite sure what method you're using. If it is that you put one of the answers on the answer line, even if it's the incorrect one, we are going to follow the method that leads to that answer on the answer line. Very, very, very important point there. Okay, now part D asks us to work out 4 times 10 to the power of 3, and that's being multiplied by 3 times 10 to the power of 5, giving your answer in standard form. Lots of times I'm marking mock exams and see where people have done the correct working out but did not put their answer back in standard form, and it will cost you. So we're going to collect our like terms here by multiplying the larger numbers together and then combining the indices. So 10 to the power of 3, 10 to the power of 5. So we know 4 times 3 gives us 12. And then we know we should add the powers when we are multiplying indices. So this gives us 10 to the power of 8. Now you must make an observation here. 12 is not a standard form number because it does not fit the criteria where it is a number between from 1 and less than 10. So therefore, I now have to rewrite 12 in standard form, which is 1.2 times 10 to the power of 1. And then I add 10 to the power of 8. Now I need to just collect them. So the final answer then is 1.2 times 10 to the power of 1 plus 8 is 9. And that's my final answer. So you must check against the criteria. Remember, we cannot have a number smaller than 1, and it cannot be 10 or above for it to be in standard form. Great. So we are moving to our next question, which asks us to solve, and solve means to find the exact answer to something. So solve x divided by 4 plus 9 equals 3. Now we'll observe the operations that we have in the question, and we're going to do the inverse of those operations. I like to start with a clear thought, so I'm going to write what the operation I have in the question and what I need to do as a result. So I have an addition of 9. The inverse is going to be subtracting 9. I have a division by 4. I'm going to need to multiply by 4. So I'm going to take care of my constant first. I'm just going to rewrite my question here. So x divided by 4 plus 9 is equal to 3. Giving myself that clear logical thought, I'm going to subtract 9 from both sides first of all. I'm left then with x divided by 4, and that's now equal to 3 take away 9 is minus 6. So I'm going to check that off. I've completed that step. Now I need to do the inverse of division by 4. So I'm going to be multiplying both sides by 4. So this will cancel out, leaving me with just x equal to minus 6 times by 4 is minus 24. Now you can see here a very simple question, but you need to apply that clear logical thought. Remember, I cannot say it enough under pressure. Things that are normally very easy that you can do fluently, you are prone to make errors because you're after that accuracy. No, you know what you're doing, you've been taught, you've prepared, you relax, and you just execute what you know. Okay, so we're going to move on to question number 8. So in this question, we're told the cost of a calculator is £3.60. The cost of a pen, so we're going to underline calculator, £3.60. You can even write that out. So for the calculator, it's £3.60. The cost of a pen is 80p. So pen equal to 80p. Write the cost of the calculator to the cost of the pen. So straight away, C to P. Remember, in ratios, the order matters. So calculator to pen, and give your answer in its simplest form. Now, if we look here, we can see that the units are not comparable because one of them is pounds while the other is pence. We need to neutralize them. It is best here to convert our pounds to pence. We know 100 pence make a pound. So if I multiply by 100 here, 1, 2, we will have 360 pence comparable to 80p for the pencil. Now we can go ahead and simplify. I can see here it's really better to divide by 10 first to change the complexity of my division. So dividing both sides by 10, I will have 36 to 8. And then I look, what is a common factor of 8 and 36? We could go for 2. Or we could go for 4. So 4 into 36 goes 9 times, and 4 into 8 goes 2 times. So the answer then is 9 to 2 in its simplest form. And make sure that whatever question you are doing, always check the units. For example, you could be doing a question on area or perimeter. You must check that the linear components are in the same unit. If they are not in the same unit, then you cannot go ahead without converting them to make sure they are the same. Okay, we are moving along and we are now going to look at question number 9. But before we go to question number 9, lots of students tend to struggle with any question concerning loci, or if you're asked to construct perpendicular bisectors and so on. So I've just interjected this here just to remind you of how to construct the perpendicular bisector of 2 points, since you're going to need that for the other question that's coming up. So here, I'm asked to draw 2 points. So I'll say draw 2 points on your page so that you can work along. You need your compass and you need your ruler and a sharp pencil. Now, if you draw these 2 points A and B, then we are going to join them by a straight line. Now, on the question that we're going to do, the line is already given to you. So you will just use the 2 points on that diagram as your reference point. Okay, now in order for us to bisect this line, we need to put our compass point at A and then open the compass to a little bit more than half of the line AB. Once we've done that, we're now going to swing in an arc to cut the line AB. I'm talking you through it and then I'm going to do it. So we keep the opening of our compass, which is the radius of the compass, and we are going to put it onto B and then swing another arc. So here we go. So I put my compass point on A. I then swing a nice smooth curve around, making sure that I have it all the way around, because when I draw the other side, the aim is to get them to be intersected. So with that radius opening of that compass, I'm now going to put it on the other side at B, and I'm going to swing another arc that will intersect the one I did before. Now I take my ruler and I draw a straight line through the two intersected points. Now I have bisected the line AB, which means that from the center to A is the same distance from the center to B. I have now constructed a perpendicular bisector to the line AB. I hope that you had gone for your compass and your ruler, and I hope that you had practiced this. Very, very, very important that you learn how to manipulate that equipment. Many students find the compass very difficult to use. Now, what I suggest for students who have that issue, rather than moving the compass, turn the paper. That is a game changer. So if you know you're not so good at turning the compass, just rotate the paper. Same effect, but you will end with a nice, clean, smoother finish. Okay, now with that being laid, we're going to approach our other question. So another important point, very thankfully I've put that in to remind myself, to remind you, you never erase your construction lines. Your examiner wants to know that you didn't just free-handedly swing that arc, that the right equipment was used, and we can tell by your construction line. Remember also in my previous video, I've spoken about a sharp pencil and the effect of that. Make sure your pencil is very sharp. Construction lines need to be very thin and clear, not retracing. Very importantly. Okay, so with that beautiful foundation laid and that reminder of how to construct a perpendicular bisector, we're now ready to take on this particular 3 marks question. We are told here that ABCDEF is a regular hexagon. Now the word regular indicates that all the sides and all the angles of a shape is exactly equal. So once a word regular is used with regards to pentagon or any polygon, it means that the sides and the angles are the same. So using only ruler and compasses, show the region inside the hexagon that is, so criteria, less than 5.5 centimeters from E, and another criteria, it must be closer to the point C than it is to the point D, and we're asked to label the region R. So we're going to use the letter R. So what we're going to do is to take this question one step at a time, one criteria at a time. So here we're asked to make sure this region is 5.5 centimeters, less than 5 from E. Now in order to identify what's less than 5.5, we have to accurately draw 5.5. So we take our compass and we're going to put it right at the point E, which is here. Then what we need to do is to open our compass onto our ruler exactly 5.5. Once we've done that, we'll put our point at E and we're going to swing an arc, which I have pre-drawn here, exactly 5.5. You can also just label on your diagram here and just say 5.5. Your examiner knows exactly what you have drawn. So I'm going to check that off. I have met my first criteria by identifying 5.5. Now, if the region is less than 5.5, it means it's going to be on the inside of the arc that I've drawn, since the arc is dead on 5.5. Okay, I'm now ready to go on to my second criteria, which says it must be closer to C than to D. Now, the only way I can know if it's closer to C than to D is to cut the line CD dead on in half using the perpendicular bisector, which I've shown you on the previous slide. So we need to split that line in half. So I have pre-drawn that, so that's what it should look like. So you would have opened your compass on D, swing your first arc, put it onto C, also swing in your second arc to intersect. Now if you see here, I have extended my line all the way through such that it will show me in terms of the arc where that region is. So remember, it has to be closer to C, so therefore it's going to be on the side of the arc that is closer to C, meaning over the side of the perpendicular bisector that I've drawn, but on the side where C is. And also it has to be within that 5.5 radius. So therefore this region here, I've asked to put R, so that's exactly where my R should be. I'm just going to also just shade it in so you can see. So it's this region. No harm done if you also shade it, but also just put the R there as well. So that little region. So if you need more help on this, you might need to do a little bit more, which I will come with as well, a little bit on construction and loci. Those questions many students find challenging, but you can see here, if you approach them one step at a time, it's really not difficult at all. Okay, so you would have scored that 3 markers. And based on marking exams, lots of times I realize that students leave that question blank. They just say, oh, I can't construct. But really, it's not difficult at all. And 3 marks is a lot to lose there. Now, clearly, before we move on, the question also says, show all your construction lines. So after you've gotten your region, your diagram remains the same. Do not erase anything at all. Well done for staying with me so far. I am absolutely proud of you. Well done. Okay, so we are now going to move to our next question. So in this question here, we're told the diagram shows a sector of a circle of radius 6 centimeters. So I underline sector, radius is 6. I have done some work around the parts of a circle. So when I was doing introduction to my trigonometry lesson, so if you struggle with the parts of a circle, feel free to go back and look at the first lesson in my series on circle theorems, and then you will be able to revise those parts of the circle. Now we're told specifically here the diagram is not drawn accurately. This means you cannot use a protractor anywhere on this question. We're asked to calculate the area, so I underline that, of the sector and give your answer in terms of pi. Now, because it's a non-calculator paper, we know that it will be difficult to get accuracy. So most of these questions on a non-calculator paper will ask you to leave your answer in terms of pi. Now we go back to look at the proportion of the circle we were given, and then we go for formula. After we've gone for formula, we're going to now substitute the values from the question into the formula. So here we go. We know that the part of the circle we're given is 3/4. So therefore, we can get the angle here by subtracting this 90° that was taken away. So here, and also by knowing our cardinal points, we would have known that the angle here is 270 degrees. So I'm going to write my formula out. The area of a sector, so area of a sector is equal to theta over 360 multiplied by the formula for the area of a circle is pi r squared. I've written my formula out. I could also have chosen to find the area of the entire sector and then find 3/4 of that. So you are flexible. If you know different methods, you take the one you are comfortable with, and that's perfectly fine. So we're now going to substitute our values in and we're going to calculate. So theta in this question is 270 degrees. So 270, and that's taken out of the total for the circle, which is 360 degrees. We then need to multiply that by pi r squared, so pi remains fixed, and the radius in the question is 6 centimeters. Do not forget that that should be squared. Very common mistake. So to simplify this, I'm going to just divide this by 10. So cancel zeros off, I get 27/36. And that's been multiplied by 6 squared, give me 36. So that would be 36 times pi, which is 36 pi. I can then go ahead to simplify by recognizing I can divide by 36. So 36 by 36 is, into 36 is 1. So therefore, multiplying, I will get 27 pi. And my answer is left in terms of pi, so nothing else to do. Very, very smooth 3-marker there. Principle applied, writing formula, substituting directly in the formula. It gives you that chance to be more accurate rather than trying to think as you go. Write it down and then do the substitution. And then look for opportunities to simplify. At this point, I want to say a common problem in the classroom is students not knowing their timetable. I cannot stress it enough. Knowing your timetable helps you to work at a quicker pace in your exam, and also it helps so much on a non-calculator paper. There's still time. Papers are about 4 weeks away. Go and do some additional practice on your timetable. Give yourself the best advantage you can. Okay? Now we are going to be going on to question number 11. So in this question, we notice that it's a graphical question. Lots of people do not love graph at all. However, you know I'm big on principles. We apply principles, and principles will get us to the correct destination. Don't be afraid of any question at all. So we're told here the population P of bacteria in a sample is recorded at different times. T represents the number of hours since the timing started. At the start, the population was 500. So we're going to underline that, 500. We know T is the time, and we're given the graph. We observe the graph before we get onto really what the question is asking us for. So we can see here, the y-axis represents the population P in thousands. That is very critical here in terms of what increments is the graph going up into. So if it's in thousands, I'm already establishing before I answer the question that if this here is 1, it represents 1,000. Now, each of the tiny squares is 5 altogether from 0 to 1. So I need to know what is the tiny increments, and I can do that by doing 1,000 divided by 5, which is 200. So I know that every tiny square is representative of 200. Got out the way, I examine now my x-axis. Now that's where the time is in terms of hours. Now that I've established all of that, I'm going to read for what the question is asking me to do. It says, use your graph to calculate. See, I told you sometimes you're asked to use the graph. So it says, use your graph to calculate how many bacteria were in the sample after 5 hours. So what we need to do here is to identify in terms of hours, 5 hours on the x-axis. We're going to use your ruler, to make a line until it touches that curve on the graph. We then go across and then we will touch the y-axis. You can see here, based on establishment of my scale, I'm just one tiny bar away from 3. And remember, we're going up in increments of 200. So that means this region here is 2,800. So because it asks us to use the graph, you must show that you have used the graph by establishing that line until it touches the curve. Then you go across, you get 1 mark for doing that. And then you will write down your answer, which is 2,800. Now, why is this important to do? When we are marking questions involving reading from a graph, there is a particular degree of accuracy that we work with. However, we as examiners, we look at the graph every student draws. So if your line is maybe, let's say, one tiny square or half a square is the mark that we will still give you if you were half a square out. We will say based on student's graph. Now, if you have nothing on your graph, but you didn't have exactly 2,800, you score 0 marks of this 2 marks. However, if you have made that on your graph and you have said 2,700 and let's say 90, and that's based on your graph, you will still score the mark because you would have been within the range of the mark scheme. So always draw the line in and show the examiner where you got this value from. Now, this question also has a part B. Part B says, what type of graph is shown above? It means that you have to be thinking about the different types of graphs. Exponential is the first one, so I go back and I visualize. And just for the purpose of this revision, I'm just going to remind you of what the exponential graph would look like. So I'm just going to use the L-shaped Cartesian plane. Your exponential graph would come from here all the way along. If it was a reciprocal graph, I'm going to use the T-shaped Cartesian plane. Reciprocal means if I have a graph here, I would see its reflection on the other side. So I know it's not a reciprocal. Notice I haven't identified exponential yet, though it seemingly is, but I have to explore the other options as well. Now for the cubic graph, remember the cubic graph looks like a wave. So I'm just going to do a cubic graph where I pass through the center. It's like a wave. So clearly this is not a cubic graph. And then my quadratic graph would produce a parabola. So for the quadratic graph, it could either be the U-shaped parabola, or it could have been inverted this way. Clearly that's not it as well. So clearly from my exploration of the different graphs, I can see my graph is exponential. And this is how you reason. Don't just go ahead and circle. Explore the other graphs as well quickly and just think about them diagrammatically before selecting your answer. Now, once you apply the principles that I am sharing with you now, it will help you to be so much more calmer as you approach each question in your exam. And calm is really what we are after, because it helps you to have that clear thought. Do not just think about, oh, I'm in my No, you have studied, you have been taught, you've interacted with past papers. So just execute the paper and do it in a calm, sequenced, logical way. Now, with all of that being explored there, we're now going to move on to question number 12. Another sometimes tricky topic for a lot of students. Again, we take our time, we read, and we take the numbers from the words. So in this question, we're told the Venn diagram below shows information about 200 students. So I underline that. I'm going to write in set notation, my universal set is 200. Straight away, I begin to give myself a focus. Each of the students was asked if they have any brother or sisters. So brother, sister. 3/8 of the students have a brother and sister. So 3/8, we know in set language, and indicates the intersection of two sets. So to write that off, I'm going to put B intersect S, 3/8 as a fraction. Now in total, 105 students have sisters. Now I've specifically put the circles here in different colors, so all of the elements in the red circle for sisters should add to 105. So I'm going to put that the number of elements in the set S should be 105 when I add them all up within that circle. Now, the number of students with brothers was 15 less than the number who had sisters. So at the moment, I don't know the people who had sisters, so that's going to be sisters only. So I'm going to wait and then come back to that part. But key thing here, I have highlighted and make reference and visualize every single part of the question. I'm now going to go back and I'm going to do them one at a time. So the first thing I can do here is getting my intersection, and I'm told that 3/8 of the total, and the total was 200. So we go 3/8, and remember in mathematics the word of indicates multiplication. So I'm going to now, so this here is where my timetable skills is going to help me, because I can see here, if I put this over 1, I can make this simpler by dividing first using common factors. So the highest common factor of 8 and 200 is 4. So 4 goes into 8 2 times. 4 into 20 goes 5 times and into 0. So there are 54 4s in 200. Now I can either multiply across, or I can also half 50. And I'm going to take the root of half in 50 because it will make it simpler. So I will have 3 multiplied by, I can do 50 divided by 2, which is 25. It's easier to multiply 25 by 3, or just add 3 sets of 25, which is 75. So that is my intersection. I go ahead, close my gaps on the diagram. I'm going to now put that 75 in, and there we have the intersection. So I'm now going to tick that part of the question off. Now I go back to my question. It says in total 105 students had a sister. Remember, that includes everything in the circle, of which we already know 75. So I can find sister only by doing 105. So I'm going to write S only here. Show your examiner what you're thinking. Will be 105 take away 75. So I look at, see, I've put that in a column method. I do not trust my mental math at the moment, because I know I'm under pressure in this exam. So I'm inking everything I'm thinking. So I subtract 5 take away 5 is 0. 10 take away 7 is 3. So that is 30. And also I just do a rough check. 75 plus 30 gives me 105. I am dead on accurate here. So I go ahead and I tick that bit off. Now I go back to my question here. My question told me the number of students with brothers was 15 less than the number who had sisters. Now sisters is 30, and 15 less than that is 30 take away 15, which is also 15. I put that on my diagram. On my way, I have one thing left to do on this 4 marker, and that is to get the number that is not included in brother or sister. So it is B union S complement what is not a part of those sets. So what I need to do here is to subtract what I've got in the Venn diagram from the total. So I'm going to add them all up, what I've got here, and then I do my subtraction. So 75 plus 30 we knew was 105. So 105, and we're going to add 15 to that. So that gives me 0, 1, 120. Now I need to do 200, take away 120, which gives me 80. And I put that outside, and there I have it. I have completed that for marker. Brilliant. You can see that clear logical steps is quite helpful in getting you through your paper, and also accurately. So far, if you were able to do that, you would have lost no marks so far. And I trust you to employ the skills that I am telling you to use. And that way, you will put that grade away. You will come out on results day celebrating your victory in your exam. Top grades, that's what we're after. Now let's have a look at question number 12. The diagram below shows information about 200 students. So I'm going to go ahead and I'm going to identify and underline my 200. That's my universal set. So I'm just going to go ahead and put the universal set is equal to 200. Each of the students was asked if they have any brother or sister. So I'm just going to highlight the elements here is brothers and sisters. 3/8 of the students had brothers and sisters. So that indicates the intersection of the set brother and sister. So I'm just going to go ahead and do brother intersects sister, and we're told that that is equal to 3/8. We carry on reading. So in total, 105 students had sisters. So all of the set here, which I've highlighted in red, all of the elements within the circle, that's the intersection and S only, all of that should add to 105. So I'm just going to write the number of elements in the set S should be equal to 105. Next point of information, the number of students with brothers was 15 less than the number who had sisters. Now I'm told that all the students who had sisters is 105. So I know that brothers in total will be 105 take away 15. So we can get back to what that number is in just a moment. So just laying everything out, and then we'll deal with stuff one part at a time. Now, what we're asked to do is to complete the Venn diagram. So now that I've laid all my information out, I can now go ahead, go back through the question and deal with one part at a time. So we know the universal set is 200. We know that the 3/8 of all the students has brother and a sister. So that's the first part we're going to tackle and fill in the intersection on the Venn diagram. So we then need to find 3/8 of 200. So 3/8, and we know in mathematics the word of means to multiply. So I'm going to do 3/8 multiplied by 200. So I need to find a common factor of 8 and 200. So we can start with 4. So 4 into 8 goes 2 times, and 4 into 20 goes 5, and into 0, 0. So that means 4 into 200 goes 50 times. We can take opportunity here either to multiply 3 by 50 and then half the result, but it may be easier to half 50 first and then multiply the result by 2. So by 3, sorry. So 3 times by half of 50 is 25. So 3 times 25 is equal to 75. So we've completed the section for the intersection. So we're going to put 75 in the middle. So we can check that off. We have completed 3/8 who has brother and sister. So we then go back to our information. In total, 105 students had sisters. So with us putting in the intersection, we have put in a part of that 105. So what we need to do now is to go ahead and do a sister only would be equal to 105 take away 75. And again, this is a non-calculator paper, so I would suggest don't just go ahead and calculate it in your head. Rather, write down 105 take away 75. We can see here that 5 take away 5 is 0, and then 7 take away from 10, that's 3, so it is 30. So we then put that in sister only. So we check that off. We have now completed that section with regards to 105 students having sisters. We go back and we read, the number of students with brothers is 15 less than the number who had sisters. And we have written that here for our point of information. So all we need to do now is to go ahead and to subtract 105 take away 15. So we can see here 5 take away from 5 is 0 and 10 take away 1 is 9. So that means we expect all of the elements in the green circle to add to 90. Now we can take away 75 from 90 to get that part in B only. However, since we know that all the elements in S is 15 more than the one in the brothers, we can also deduce, we could just simply take away 15 from 30 to find the result that's here in B as well, and that's the easiest route there. So we're going to do brother only would be equal to 30 take away 15. So I put that 15 here, and I also check if this is true. 75 plus 15 gives us 90, and we did say brothers should be 90, so we are sure that we are correct. So now there is one last bit to fill in. So we know that all the elements in the Venn diagram, including outside in the box, should add to 200. I knew that sisters was 105, so I can add 15 to that 105 and then subtract from 200. So I'm going to do 105 add 15, which gets me to 120. So in the A union B, or let's just use the letters we were given, so B union S would be equal then to 200 take away 120, and that gets us to 80. So in the Venn diagram on the outside is 80. A good practice here would be to add them all up and to make sure that that's true. We knew 15 plus 75 was 90. 90 plus 30 is 120, and 120 plus 80 is 200. And there we have it, just like that. I want you to make sure that you are paying attention to the questions I ask myself, how I navigate each aspect of the question, underlining key things and working one step at a time. So, nice and easy, smooth 4 marker there. And with that being said, now we move on to our next question. So question 13a asks us to factorize x squared minus 36. I hope that you can recognize here that this is the difference of 2 squares. So I go ahead and I write both of my bracket pairs. I then need to do the square root of x squared, which is x. I put that in the left hand side of both of my brackets. And then I need to do the square root of 36, which is 6. I put that on the right hand side of both brackets. Now what I need to do is to just put one add, one subtraction sign in each of my brackets. 1 mark, nice and smooth. Now we can see this is a follow-up question 13b. And if we look in the denominator here, we recognize that we will need to use the values that we have in part A. So some of our work is already done for us. So we need to now focus on factorizing the quadratic here. So we've got 2x squared minus 19x plus 42. We go ahead and we identify what is A. So A is the coefficient of x squared, which is 2. B is the coefficient of x, which is negative 19. And C is our constant, which is positive 42. We go ahead and we find AC. So we're multiplying A by C, which is 2 times by 42. And that's equal to positive 84. So now I need two factors of 84 that will add to minus 19. So those two factors are 12 and 7. But remember, we're trying to get negative 19. So that means both our factors have to be negative. And we check. Negative 12 plus negative 7 gives us negative 19. But when we multiply them together, we get positive 84. So criteria met. So what we're going to do is to rewrite minus 19x in terms of these two factors. We go ahead, we do 2x squared. We observe where to put 7 and where to put 12. We can see here minus 12 is better suited beside 2x squared. And then minus 7x and positive 42. Now that we've done that, we're going to factorize by grouping. So we need the highest common factor of 2 and minus 12, which is positive 2, and x squared and x, which is x. We then go ahead and open our bracket. So what multiplied by 2x gives 2x squared? That's x. And what multiplied by 2x gives minus 12x, that's minus 6, we check. 2x times x is minus 2x squared, and 2x times by minus 6 is minus 12x. We know the other bracket will also be the same. We go ahead and we put that in, and then we check what multiplied by x gives negative 7x, that's negative 7. We check negative 7 times by x gives negative 7x, and negative times by a negative here will give us positive 42. Last step now is to collect our bracket pair. So remember, we get our first pair by taking the terms on the outside of the bracket, which is 2x minus 7, and one of the common bracket pair, which is x minus 6. We have already done the difference of two squares, so now we're going to write our denominator. So it's x plus 6. That's what we got from factorizing here. And x minus 6. We can see here we also have a common factor in the numerator and also the denominator. So we could just cancel out x minus 6. So our final answer is 2x minus 7 divided by x add 6. 3 marks. Well done for getting this far in the lesson. Now, if you still need some more help on factorizing with coefficient greater than 1, just go to the channel where I've done a complete lesson on that and also some exam questions as well. Now we're going to go on to part C of question 13. So here we are given an identity. We're told that 6 being multiplied by ax plus 4 plus 10 is identical to 3x minus 2b, and we're asked to work out the values of a and b. So first step is to expand our brackets. I'm just going to rewrite this here. So 6 bracket ax add 4. So 6 times ax is 6ax, and 6 times by 4 is 24. Remember, we also have a plus 10, so we'll put that plus 10 in. And then we're going to simplify and then make it equal to the right-hand side. So we got 6ax plus 24 plus 10 is 34. And then that's identical to 3x minus 2b. Now, if we can see on the right hand side, we have two terms. One is 3x and the other is minus 2b. So it means then we need to find the matching pairs on the right and the left. We can see here that 6ax and 3x are the matching pairs. So we're going to equalize them and then solve for x. So I'm just going to write that here. So 6ax is equal to 3x. Now, looking only at the coefficients of x, I can see 6a is the coefficient of x on the left-hand side, and 3 is the coefficient of x. Therefore, 6a is equal to 3. I then need to divide by 6 on both sides to get a. So a then is equal to 3/6, which can be simplified to a half or 0.5. So we go ahead, put that on our answer line. So a is 0.5. Now remember, in your exam, the answer line is the most important line. Now, if you have your methods correct, but you accidentally put the wrong answer on the answer line, you are not going to be scoring the answer mark. So make sure that whatever you do, the correct answer is what you put on the answer line. Now we're going to go ahead and now find b. We can see here that 34 is matching with minus 2b. We go ahead and we do 34 is equal to minus 2b. So by dividing by minus 2 on both sides, we will find what is b. So 32 divided by minus 2 is minus 17. So therefore b is equal to negative 17. And we go ahead and put that on our answer line. Nice, 3 marks. And these identities also tend to come with square units and also cubic. The same principle will apply should you see questions like those. You still find out how many sections you have. In this case, we only had 2 terms. But if you had a square, you would have had 3 terms. If you have a cubic, you will have 3 terms. And you match them just the same and solve each part separately. Now we're going to go on to our next question. Now in this question, we're told that shape A below is a 2-dimensional cross-section of a prism. The prism has length 5 centimeters. So here's our 5 centimeters. Very simple markers from here, 1 mark each for both question A and B. So we're told to write down how many of the faces of the prism will be squared. Now remember, what we have to do here is just visualize. We can see if I extend this bit here, this will form a square. Now if I extend this bit here, it will also form a square, and also at the side will also form a square. So the answer then simply is just 3 faces will be square. Now the next part of the question says write down how many of the faces of the prism will not be squares. So we just need to go ahead again, visualize the other parts that we haven't. So if we look along here where there is 13, that will be one side. If we look along from the top to here, that's 2. We also have the one at the bottom here, which is 3. There is also going to be 2 more on the back side, which will be 5 in all. So the answer is 5. So you have to be thinking, what if I had this L shape in my hand? What are the different sides I will see? Because there's another side on 2 other sides on the back of this section that we're not able to see forthcoming, and those will make 5. Simple 2 marks there. Now we need to move on to question number 15. So in this question, we're told A is increased by 10% to give B. B is then increased by 20% to give C. Write down a single decimal, we underline that, multiplier for the overall increase from A to C. Now a good way to visualize this is to draw a number line showing from A to B. So I'm going from A to B, and then I'm going to take a journey from B to C. So we were told that is 10% increase from A to B. So our multiplier would then be 100%, which we can write as 1.1. And then from B to C is 20%, so that multiplier will be 1.2. Now to get the total journey, we need to multiply the two of these together. So it's going to be 1.1 times by 1.2. Now we can see, if we think about the whole numbers, we're ultimately doing 11 times by 12, and then we can take care of the decimal. So 11 multiplied by 12 is 132. And we've got 1 decimal place, 2 decimal places, so our answer should have 2 decimal places, which means then we are dividing by 100. So moving 2 spaces back, our multiplier then is 1.32. Nice little 2 marker there. Okay, so we will then move on to question number 16. In this question, we're asked to say which one of the following equation represents a straight line graph and circle your answer. Now at this point, you should write down straight away the general form for the equation of a straight line, and that is y is equal to mx plus c. Now m is for your gradient, very good opportunity to revise that, and c is for your y-intercept. Now, the y-intercept is technically where your straight line graph crosses the y-axis. So if I just do a quick visualization here, I've got my y-axis here. So if I have a straight line crossing this line, right where it crosses over will be my y-intercept. Now, if I look clearly, graph 1, line 1, line 2, have the equation y equal to something, but the only graph that doesn't have that is the third one. So which means we need to rearrange to make y the subject of the formula. Now you can see here that I have a positive x, so I need to subtract x from both sides, which will leave me with y equal to negative x, and 3 times 3 is 9. Now that equation is in the form y equal mx plus c. I'm now in a position to see which one is in the right order and which one is the equation of that straight line. Now I observe clearly the one I just rearranged is in that form. We check that off, but if we look back at these ones, we can see we've got an x square, which indicates we have a quadratic, not a straight line at all. The other one is a reciprocal, and also elements of reciprocal there. So it is the one that was not arranged in the right order. So we never attempt linear questions unless we ensure that our equation is in the form y equal mx plus c. And that goes across the board for any question on linear graphs. Okay, nice little 1 marker there. Now this particular question we're about to move on to can be problematic for lots of people. However, knowing how to draw simple linear graphs can close this gap. Now, when you're doing this, you always take one graph, one line at a time. So we're told that on the grid, we are to identify the region represented by x is greater than 2, y is greater than 1, and x plus y is less than or equal to 8. So what we're going to do, in order for us to identify the regions, we first need to draw the lines that each of these inequalities represent. So we're going to go ahead. In order for us to draw x greater than 2, we must first of all establish where x is exactly equal to 2. Now to draw this on our graph, we need to go back to thinking about the lines that can be used to represent if we have greater than or equal to, less than or equal to, or if we have just less than or equal to. So on the graph, if we're going to draw a line that is greater than or less than, we use an broken line. So I have an example here. Broken line means less than or equal to, less than or greater than. Now, if I'm going to do equal to, I have to do a solid line. So solid line works with either of these two inequality, where the value is also a solution. So if you notice in the first one, I have x is greater than 2. So I'm going to identify on my graph exactly where x is equal to 2. But because 2 is not a part of the solution, I have to use a broken line. So here, x is equal to 2. So I go ahead and I will draw a straight vertical line. Now, a lot of students tend to mix up our y equal to something or x equal to something. Remember, if x is equal to a value, it will be a vertical line. If y is equal to a value, it will be a horizontal line passing through the y-axis. So here, I'm just going to write, this is exactly where x is equal to 2. But I was asked to do x greater than 2. It means that the values passing 2, 3, 4, 5, 6 on that side would be the region I'm thinking of. Okay, I've ticked that off. I've finished with x is greater than 2. Now I'm told here that y is greater than 1. So I look for y on the y-axis, which is here, and I do a horizontal line passing through that. Now if y is greater than 1, it's everything above the line that would be the region. We now go ahead, take that off, and we're now going to do x add y is less than or exactly equal to 8. Now this is the most tricky one out of the three. What I have to do here, I need to identify where x plus y is exactly 8. So I choose some coordinates for x and y that possibly adds to 8. So we could do 0 and 8. We could do 8 and 0. We could do 1 and 7. We could do 7 and 1. We could do 2 and 6. We could do 6 and 2. Now, in order for us to draw linear graphs, we need to have at least 3 points, because we can extend our lines and pick up other points on the graph as we go along. So I'm just going to plot these points and then draw my line. So I do 0, 8 would be here. I do 8, 0 would be here, and so on. And then I just simply draw my line in. Now, it is a solid line because we're told that it could also be exactly equal to 8. So we need a solid line. So remember, broken line, the value is not a part of the solution. A solid line, the value is a part of the solution. Now, if it is less than that line, it means that the region will be below the line. So that means here in the triangle is where the region will be, that is greater than 2, greater than 1, but less than x plus y. Very beautiful question. Now in your exam, this question could also have extended into finding the area of the region. So all you would have needed to do in that case is to pay attention to the triangle, apply the formula for the area of a triangle, which is half base times by height, and we will make sure that you count your squares properly for your base and your height, and just find the area. Now, if the question was drawn on a centimeter grid, you could also have counted the squares to find the area of the triangle as well, just to say different ways that this question could be posed at you. Now, with that being said, let's have a look at our next question. So in this question, we're asked to convert 0.47 recurring to a fraction. Now, this is a very common question on an exam. I guarantee that over paper 1 to 3, you will see at least one of these questions. So it's very, very important that we can score these 3 marks here. So we're asked to convert 0.47. We can see the dot is over the 7, which means the 7 recurs. We don't know what the fraction is, but we can always rely on our algebraic skills. So let that fraction be x. So we start off by doing x is equal to 0.4 and then just write out a few of the 7s just to show that that continues to happen. We then need to make some scale factors by multiplying by 10 or powers of 10. Could be 10, could be 100, could be 1,000. Now, one of the things that we're aiming at here is to create, when we subtract the two equations that we choose to use, to get a whole number. So sometimes you have to look at different factors to see which one is likely to work together to give you that whole number. So we're going to go ahead and multiply the equation by 10 to do a scale factor, create another equation. So multiplying x by 10 and also the decimal by 10, we will now have 10x on this side, and moving one place to the right when multiplying by 10 will give us 4.77. We can match up those 7 because remember the decimal recurs, so we could go ahead and do that. Now I can see here if I subtract x from 10x, I'll get 9x, but if I subtract 0.47 recurring from 4.7, I'm still going to get a decimal. So let's go ahead and try to make another scale factor, this time by multiplying by 100. So if I do x times 100, I get 100x, and multiplying 0.47 recurring here, we will now have 47.77, and again we just write out enough 7s there. Now I can see that if I subtract them, x, 10x and 100x, now I will get a whole number, which is much easier for me to navigate. Now if I was a student, I would just go ahead and write a smaller equation underneath, so it's very much easier to see what I'm working with. Very important here that we line up our decimal points properly. Now we're going to now subtract 10x from 100x and also on the other side. So 10 take away from 100 will give me 90, hence this is 90x. Then 47, you can see all of the 7s here, they line up, so they will cancel out to 0. So basically I'm just doing 47 take away 4, which is 43. Now we need to divide by the coefficient of x, which is 90. So dividing by 90 on both sides, I can see here I've got x left and 43 90ths. I look to see, my question however didn't say in its simplest form. However, some questions do say that. So we look for opportunities always once we are working with fractions to see if we have reached our simplest possible term. There are no common factors with 43 and 90 here. So our final answer is 43 90th. So that would be the fraction that we would have gotten that produces that recurring decimal. Well done for getting so far. And this question, as I said, is an application question as well. So make sure that your skills on this question is really, really good. Sometimes it's even 4 marks for this question rather than 3. So it depends on the complexity of this style of question, can rank a higher mark. Okay, so now we're going to go to question 19, which has to do with sequences. Now, I'm sure most students are very good at arithmetic sequence. This is a question around arithmetic sequence. However, it relies heavily on your algebraic skills, since we are not given numbers, but we are given expressions. Now, the same principle applies if you had numbers versus if you had an algebraic expression. So we read our question and then we apply the principles. So here we're told the first term of an arithmetic sequence is equal to 3a add b. So I'm just going to go ahead and put this as my first term. The fourth term of the sequence is equal to 15a minus 15b. So this is term 4. Now write an expression. You can see clearly here, because it's algebraic, we will not be able to get a value, but we are rather going to get an expression for the fifth term of the sequence, which means that the missing terms here is term 2 and term 3. So how do we approach this question? First of all, we're looking to see the gaps in between 1, 2, 3. So there are 3 intervals in between them. Now what we want to find out is, what is this sequence going up by? What we need to do here is to subtract the first term from the fourth term, and then we're going to split that in 3 parts, and now we will know the increments of the sequence. So we're going to go ahead and we're going to do 15a minus 5b. We're going to subtract 3a plus b. At this point, I pause to talk about a common mistake that students make. You cannot just go ahead and do minus 3a plus b. You must put what you are subtracting into a bracket. So minus, inside the bracket, 3a add b. Now you're going to use the negative on the outside of the bracket to expand the bracket. So that negative is like minus 1. So we go ahead and we do 15a minus 5b. Negative times 3a will be negative 3a, and the negative times by positive b is minus b. Now we can simplify. So 15a take away 3a, that's 12a. And minus 5b minus b is minus 6b. Now, because we're going in intervals of 3, we now need to divide this by 3 to find out what it is that we're going up by. So I'm now going to do divided by 3. So 12a divided by 3 gives me 4a, and minus 6 divided by 3 is minus 2, and b is our variable. So we check and see if that's true. So 4 times 3 is 12, and a. So 3 times minus 2 is minus 6b. So this is what the sequence is going up into. Now we are asked to find the 5th term. So we go ahead and we add term 4 with what we're going up by in the sequence, and that will get us the 5th term. So we go ahead. So we're going to write the 5th term is equal to 15a minus 5b plus 4a minus 2b. And then we simplify. So 15a add 4a is 19a. And minus 5b minus 2b, that's minus 7b. Another beautiful question on application, and is worth 3 marks. Awesome. And you can, if you have time in your exam, you can go ahead and test if this is true by starting from term 1, adding on what we're going up by, and keep doing that until you get to the 5th term, and then you'll know you are correct. Now we're just going to go ahead and we are going to be working out the 20th question. So we're told here that Rafa takes a journey in 2 parts shown in the diagram below. He's going from A to C. However, he's done that in 2 parts. He's gone 20 miles from A to B, and then he leaves from B to C, and that journey between B and C is 40 miles. So I like to always underline my key things in the question. Distance between A and B, 20 miles. Distance between B and C, 40 miles. Now, this is not drawn accurately. Very important to note here. So Rafa travels 30 miles per hour, between A and B, and then 50 miles per hour between B and C. How long has his journey from A to C took in minutes? So now we're going to break this apart. We know that once we're talking about distance and time, we're looking at our triangle that refers to speed, distance, and time. So I'm just going to draw the triangle here. A very good principle to visualize my formula. So I know distance is always at the top of my triangle, and then I have speed and time. Now, if I want to find the speed, I'm going to do distance divided by time. If I want the time, I'm going to do the distance divided by the speed. Now we are talking about, in this question, the time. How long? So that indicates time. So we're going to write a formula. So what we have to do here is to work in two sections. Find out the time it takes from A to B, then find the time it takes from B to C, and then add them all together. Paying attention to the degree of accuracy, we're asked to represent this answer in terms of minutes. So we go ahead, we're going to look at from A to B. So we want the time taken. We know time is equal to distance divided by speed. The distance in the question is 20 miles. So 20 divided by the time taken here, we're told, is 30 miles per hour. So we're dividing by 30. We can see that dividing by 10, we can simplify this to 2/3, which means we need to find 2/3 of an hour. So we go ahead and we do 2/3 multiplied by 60, since 60 minutes are in an hour. I can see here, I can divide 3 into itself once and into 60 20 times. Then 2 times by 20 is 40, so this is 40 minutes. I now go ahead and calculate from B to C using the same principle. So from B to C, the time is going to be, we're told that the time is distance divided by the speed that we're working with. So let's go. Distance divided by speed is 40 for the distance, and the speed that we traveled at was 50. Again, we're doing 40 divided by 50. We can simplify by dividing by 10, make it simpler, which will be 4/5. Now I need to find 4/5 of 60. So I need to do 4/5 multiplied by 60. And again, if you know your timetable, this is easy calculation. 5 into itself goes once, and into 60 goes 12 times. 12 times by 4 now gives us 48 minutes. So all we need to do is to get the total by adding them together. So the total here would be 40 minutes plus 48 minutes, which gives us 88 minutes altogether. I write my answer and show 88 minutes. Well done. So once you have where your journey is broken in two parts, you focus on each part and then bring it back together for the final answer. Okay, now we're going to our next question, question number 21. So before I start this question, just checking, did you remember to subscribe? And also, did you remember that we are also doing short questions on TikTok, 4 markers exam style question? If you haven't subscribed yet, go ahead. Hit that subscription button, hit the notification bell so you know when the other lessons are uploaded as well. Now, also remember to share with a friend. They too need to do well in their exam. Okay, so question number 21. We're asked here to rearrange t equal 4 divided by a plus the square root of n to make a the subject. Now remember, when we talk about the subject of a formula, we're talking about what the equation is equal to, which is most likely to be seen on the left hand side. So in this question, t is currently the subject. So the subject a is what is being worked out. So the aim here is to have a on its own. So we go ahead. I like to always navigate my thoughts by looking at the operations I currently have in the question, and I will need to do the inverse of those operations. So I can see here I have a plus, so I'm going to write have and do. I have an addition and I'm adding the square root of n. I'm going to need to subtract the square root of n. I also have a division by a, so I'm going to need to multiply by a. Okay, now we go on to do the first part. So I'm just going to rewrite the question for clarity here. I've got t equal to 4 divided by a plus root n. So my first step, I'm going to take care of my constant, which is in this case the square root of n. So I need to subtract root n from both sides, minus root n. Now I'm going to tidy up my left hand side by just writing t minus square root n, and that leaves me with 4 divided by a. So I'm going to check that off. Little tick, I've done that bit. Now I need to do the inverse of division by a, which is multiplication by a. So if I multiply both sides by a, key point here, make sure that you put your multiplication in bracket. So you can see that t and minus root n, both of them are being multiplied by a. It is very, very important to do that. Now, having done that, these two a's cancelled out, leaving me with just 4. Now, I want a to be on its own. So therefore, I need to do the opposite of multiplying a by t minus root n. So I'm going to divide both sides by t minus square root n. T minus square root n. Now these two will cancel out. Now I've got a to be my subject. So I'm just going to rewrite that to tidy things up. So a then will be equal to 4 divided by t minus the square root of n, and there goes my 3 marks. Clear, logical thoughts. Remember, we're talking always about the inverse of our operation. So I ask myself, what operations are in the question? And then I ask myself, what are the inverse of those operations? And then I deal with them one operation at a time. And that guarantees your clear thought and manipulation of what you're doing. And again, rearranging formula comes up a lot on your exam directly, as in this question, and also indirectly. For example, you know the volume of a sphere, and they will say, what is the radius? What's a formula for the radius? If you are calculating the radius, your knowledge of rearranging formula makes that really much easier for you, because you can go ahead, manipulate that formula, rearrange to make the radius the subject, and then it's just simply easy to substitute into that equation. Okay, now we go to our next question, another very, very common topic on your exam, cumulative frequency. Now, here is some information about how long 80 people spent shopping. Perhaps these are women, because men would love to say, you know, women spend a lot of time, young girls love to spend a lot of time shopping. We like to look at different things. So a very important question, and also we can relate to long lengths of shopping time as we go. For whatever reason, we may be in the queue waiting to pay, but we spend a lot of time sometime. So this connects to our real life. Okay, so we're told here that time t in minutes, we're given some intervals here from 0 to 10. We have 10 to 20, 20 to 30, and 30 to 40. And the frequency here, 20, 32, 18, and 10. We're asked to draw a cumulative frequency graph of this information. Now, once we hear the word cumulative, I'm thinking I've got the frequency, but cumulative speaks of carrying on. So I need to, the questions sometimes give you another bar, another part of the table that indicates to you that you need to do cumulative frequency. But as you can see, this particular question doesn't. You have to remember that cumulative means consistently adding on. So you have to now create another part of the table for yourself. So I'm just going to go here and write CF for my cumulative frequency. So you draw that on, and then we're going to start off by putting, first of all, the first number we're given in our table, which is 20. We go ahead and we add 20 plus 32, which is 52. We then need to do 52 plus 18, which is 70. And then we need to do 70 plus 10, which is 80. Now, we knew that there were 80. So how I know I've added correctly is if I got 80 after doing the cumulative frequency. So now I have enough information to draw my graph. Now, very importantly here, we always use the upper bound of our intervals to plot on our graph. So I'm circling that. We must always use our upper bound of our intervals along with our cumulative frequency. We go ahead and we plot that on our graph. So first one I've got is 10, and 10 goes up to 20. So I go 10 on my graph, go up to 20, plot that here. We could also just do 0, 0 to indicate our starting point. Now I go to 20 goes to 52. So I look at my scale properly. I can see I'm going up in tens. So that means if there are 5 spaces in between, 10 divided by 5 means that each tiny square is worth 2. So I go to 50. So I'm doing 20 and 52. So I go to 50, which means 1 space after that will be 52. Then I go for my 30 to 70, 30 to 70, nice and smooth one there. And then I go 40 to 80, another smooth one there as well, dead on. Now, because I'm doing a cumulative frequency, I do not use my ruler to connect the point. I do not use my ruler to connect the points. So I need to do a nice smooth curve. So I'm going to do my best here. From 0, I'm going all the way up with my pencil, and I go all the way through and connect my points. Now I have drawn my diagram. You can see that is 3 marks. So you'd have gotten some marks from doing your cumulative frequency. If you had to label the graph yourself, you would get some marks for that. But this question was very, very kind. Everything is labeled. And so then you just needed to plot your upper bounds against your cumulative frequency, and that is for 3 marks. Now, we also have a part B for this question. The question says, those who shop for less than 25 minutes spend an average of £5 each. Calculate an estimate for the total amount of money spent by these shoppers. 2 marks. So there are 2 approaches we could take to this question. We need to find out how many people there are and then multiply that by 5. So we can go back to the graph. We look for 25. We draw a line, go all the way up, touching the curve. We can see here, this here is 61. So I will go back on the next slide. It's 61. We know it's 61 people, so that's going to be 61 multiplied by £5. So 5 times by 1 is 5, and 6 times 5 is 30. So the estimate for the total is 305. Now we could also have gotten that from the graph, the table as well, and I'm just going to quickly talk you through that. So we need 25, which is halfway between this boundary. So half of 18 is 9. Then if you add 32 and you add 20, all of that also gives you 61. Okay, so make sure that you practice a lot of these questions, because as I said, it's a very, very popular question on your exam. So you learn you could find that from a table, you learn you could find that from the graph. But practice, remember, I can't say it enough, practice does make things permanent. Now let's go into our next question. So on her journey to work, Helen passes through 2 sets of traffic lights. Another real life context question. The probability that the first set of traffic light is green is 2/10. The probability that the second set of traffic lights is green is 3/10. Complete the tree diagram. Now, we know that probability always adds to 1. So, to complete this tree diagram, we need to say what plus 2/10 make 10/10, which is 8/10. I go ahead and I write that on my tree. On the other side, we have 3/10, so 7/10 add 3/10 make 10/10, which is 1 wall. Now, we just simply need to replicate that on the tree. So 3/10 and 7/10, and we always check and make sure that they add to 1. So we can see 2/10 plus 8/10 is 10/10, which is a whole, and also 3/10 plus 7/10 gives us 10/10, which is a whole. 2 marks to complete that tree. Now we also have a part B to this question, so let's go. So part B asks us to calculate the probability. Remember, probability is always written in one of 3 forms: fraction, a decimal, or a percentage. A very important note there. So we're asked to calculate the probability that at least one traffic light is green on Helen's way to work. So at least one means one, or it could be both of them is green. So a very simple way to do this, we know that to calculate probabilities, we always multiply across our branch. So if I look here, that means I want, it could be green, green, or it could be green first, then not green, or it could be not green, then green. What it cannot be is not green and not green. So an easy way to do this question, since we know probability is out of 1, or we could say out of 100%, then we can go ahead then and work out not green times not green and then subtract that from the total. So not green on the first one is 8/10 and not green on the second one is 7/10. So we need to multiply those. So we go back here, not green is going to be, so the probability of not green, so I'm just going to put n and n for not green, we said was 8/10 multiplied by the second one, which was 7/10. We go ahead and we simplify the fraction. So 7 times by 8 is 56, and 10 times 10 is 100. Now I know then that we're going to have a total of 100 parts, so we could write our whole as 100 out of 100, and then subtract 56 hundredths from that, we will get our answer. So 56 take away from 100 is 44. Out of 100, we get 44 hundredths. Now that could also be simplified. Now, most of the times for a probability question, unless they say give your answer in its simplest form, if you have written 44 hundredths, you would still have scored the mark, but as it relates to fractions, it's always a good idea to simplify. So we could simplify, so I'm just going to take that opportunity. Now I could divide by 2, half of 44 is 22, and half of 100 is 50. I could then go ahead and half this again. Half of 22 is 11, and half of 50 is 25. So in its simplest form, it will be 11/25. However, as I said, most of the times you are not asked to simplify for the lowest, and sometimes when you try to do that, you end up messing up the final answer. So having written 44 hundredths or 0.44 as a decimal, or 44%, you will still get that mark. Okay, we then move on from there to our next question. Now, in most exams at the back of our paper, we will find questions on the sine graph, the cosine graph, the tangent graph. Lots of students find these questions quite difficult. They're usually like 1 or 2 markers, so no big worries there. But remember, the difference between our grade boundaries is a mark, 1 mark. So if we can score all possible marks, then we are headed in the right direction. So we read the question. We're told here is a graph of y equals sine x for the values of x from 0 to 360 degrees inclusive. In parts A and B, the graph of y equals sine x is shown as a dashed line. So they're giving you those values on the graph in a dashed line, and on the same graph, we're going to be asked to do some things. So we go to the question, part A. We're told here is the sketch of y equals sine 2x. Now, very important part here, so I'll underline that. For the values of x greater than or equal to 0 and less than or equal to 360 degrees. Now, what we're asked to do here is to sketch that graph. Now, when we have coefficient of x here being 2, this means that the period of the graph, which is usually 360 degrees, will be halved. So where we have 90 degrees here, our graph will then be at 45 instead. Half of 90 is 45. So a good practice here when sketching these graphs is to plot the points first and then use our pencil to connect them. So we can see instead of 180, we're now going to have 135, which is between 90 and 180. So we're going to plot our 90, plot this point here. So as I said, the graph is going in 45 degrees instead of the 90 degrees intervals we had before. So this point is now going to be here. We got one at 270, one below here, and the other at 360. Now that we've plotted all our points, we now just need to connect them by our curve. So we just go here, go down, we go up, and so nice and smooth. That's what the graph would be. So we can see that the period goes by 45 degrees this time because we have now gone half of what it used to be. So the period is divided by 2. Now we're going to go to part B of this question. Again, the original sine graph y equals sine x will be given in a dotted line, but this time the context of the question has changed. We're told here that we are to sketch the graph of y equal 2 sine x. Now if you notice here, the 2 is before sine. This means that the amplitude, which is the height and depth of that graph, is going to be doubled. So if you notice here, the amplitude was 1, the amplitude is now going to be 2. So again, all I need to do is to plot my amplitude for 2, and also it will change on this side by -2, and everything else remains the same. So I can go ahead and put my points in, and then I'm just going to draw my curve. So I go up amplitude of 2, I come down, go through 180 degrees, go to -2, and then back up to 360 degrees. So when I've got my number before sine, it is the amplitude of the graph that's affected. If it is on the other side after, then it is the period of the graph that's affected. And so you would have been able to score those 2 marks that most students tend to just skip over on an exam. All right, we move on to a vectors question, another question that tends to be on the back of our paper. Lots of students are terrified of vectors, but let's just go ahead. Simply talking about directions we need to take from one point to another. So just like we're going out and we look on our train and our bus apps and we plan our route, what is the best way to go, vectors rely on traveling routes as well. So when we're asked to move from one point to another point in vectors, we're looking to plan our route that we're going to take. So we're told here that PQR is a parallelogram where PS is equal to A. When we're reading, we identify with the diagram as well. So P to S is equal to A. Now, very importantly here, as it relates to vectors, the direction of the arrow matters. If we're going in the direction of the arrow, we are going in a positive direction. However, if we're going against the direction of the arrow, it will be a negative. Very important thought. So we're told that PQ is equal to B, again, going into the direction of the arrow here. Now, M is the midpoint of the line SR. QY to YR is equal to 2 to 3 in ratio, and X is the line PQ. Now, we're asked to write down the vector PM in terms of A and B. So again, route planning. I want to go from P to M, so I'm just going to draw a line to connect my start and my end point. Now, I can see here that the question told me this is a parallelogram. So that means if PQ is equal to B, then SR is also equal to B. However, M is my midpoint, so that's going to be from S to M will be half B. And so then I have enough information now to go from P to M. So to go from P to M, I need to travel P to S first of all. So I'm just going to write here that PM would be, vector PM would be equal to PS, add, I now need to go from S to M. And then once I add those two together, I would have traveled from P to M. So again, you can see here is like going, let's say we're going from Croydon to London Bridge, and then we need to take another train from London Bridge to whatever destination we're going to. So we break our journey in two parts. So here, from P to S, we're going in the direction of the arrow, and the variable there is A. So PS is vector A. Plus, we're going from S to M, which is half of B. We know that these are unlike terms, so we're not able to add them together. So that is our final answer. So the answer then is A plus a half of B. Nice little one marker there. Now we move on to our next question, which is going to be our final question. Now here, another tricky topic for some people, where we are asked to use exact trigonometric values. Here we're asked to work out 9 sine 60 degrees, take away 5 root 3. This question is a question I have seen by over the years. Lots of people try to stay away from these questions, but you can see this question is worth all of 4 marks. 4 marks is a lot of marks to use, so let me help you to navigate this question. So 9 sine 60 means 9 multiplied by sine 60. Now sine 60 degrees is equal to root 3 over 2. So we write that, we get a mark for just writing what is sine 60 degrees. So even if it is that you didn't know where to go from here, at least out of that 4 marks, you have gotten 1 mark already. So write down what you know, even if it's not a lot. Very helpful to put those little marks in. So I'm going to now do 9 multiplied by root 3 over 2. We are subtracting 5 root 3. Now we know that once we have a root in our denominator, we now need to rationalize. So this is where our knowledge of surds will come in beautifully. So I'm going to rationalize 5 root over root 3 by multiplying both numerator and denominator by root 3. So simplifying this, I will get 9 root 3 over 2. And I'm subtracting 5 times by root 3 is 5 root 3. And then root 3 times root 3 is root 9, and the square root of 9 is 3. Remember, when I multiply 2 identical roots, my answer will be the number without the root. Now that I have 2 numbers in my denominator, I now need to rely on my skills of subtracting fractions. So I need to find the lowest common multiple of 2 and 3, which is 6. So I go ahead and I do 2 into 6 goes 3 times. I need to multiply 9 root 3 by 3. So that gives me 27 root 3. And I need to do 3 into 6 goes twice. So I need to do minus 5 root 3 by 2, and that's 10 root 3. Now that I've done that, I can go ahead and simplify. So 27 take away 10, that's a coefficient of the roots. That will give me 17, and the common root is 3. 6. Now I go back to my question, because my question asks me to give my answer in the form A over B root 3. So therefore I can conclude my answer is 17/6 root 3. So I can see, I know I'm correct. The reason is my root that I got was root 3, and in the answer the question, it tells me that my root was going to be 3. I can even go ahead to show my examiner I know what I'm talking about by writing what is A. So A would be 17 because that's the numerator here, and B would be equal to 16. Sorry, so equal to 6. So it's not a requirement for you to write what is A, what is B. However, you can just show your examiner that I know which part of my fraction is A and also B. And there you have it, 4 marks. I know that you are there thinking, my gosh, it's really not as hard as I thought it was. No, just break the question in parts. And remember, I've talked about in previous video that wherever you see a mathematical concept that can be applied, even if it's not that topic you're doing at the moment, because of the spiral nature of the mathematics curriculum, then wherever an application can be made, you make that application. Now, our final thoughts. Thank you so much for staying all the way through this paper. And I hope that I've managed to help you to feel more confident in doing your paper 1. You can see here all the things you've learned over those 5 years are just summarized here in a paper. And you know how to do these questions. So you just need to be calm. You just need to relax and just simply execute what you know. And I guarantee that you are going to do exceptionally well. Now, with all of that being said, I'm just really excited that I could do this for you. And I hope that you really benefit from the content. And if you have benefit from this content, go ahead and share. Subscribe if you haven't yet. Hit the notification bell. And remember, we are also on TikTok, where we are working out additional exam questions on the go. So you're on your phone, you're in the bus, you can be watching some of these questions as you go along. And that will be really, really helpful. Thank you so much for watching.